Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on trie data structure. Okay, we have to implement a trie data structure. Let's just directly jump into the problem statement, understand it, and start solving. So last time we have solved the course schedule. You can find it in the list. Let's start with implement trie. So before moving forward, I must alert everyone that this is going to be a long video. Okay. Let's start with the question and then we'll understand it. Okay. So we have to implement a trie data structure. A trie, pronounced as trie or prefix tree, is a tree data structure used to effectively store and retrieve keys in a data sets of strings. There are various applications of this data structure such as autocomplete and spellchecker. Yes, that is key thing to note. If you know that when you are writing on your mobile or you are sending messages and this autocorrect that keeps happening, that actually uses trie data structure and you can use the same. Okay. So all we have to do is we have to implement the trie class which is given here, and we have to implement few of the methods that they have given. That is the insert, search, and startsWith. Okay. Trie initializes the trie object. Insert is going to insert the string into the trie. Search is going to search for it, return true or false in case. And startsWith is actually going to check if a string starts with a prefix that is given. Okay, let's understand it from the code example. Okay, let's say trie is there, right? We created a trie, we inserted a string apple. So apple has been inserted. Next time we are searching for apple. So apple exists in a trie data structure. So we return true. Next time we are searching for app. So app does not exist in a trie data structure because this P is not the end of the string. It's not the end of the word. This E must have been marked as the end of the word. So we know APPLE, at E it ends. So we can say yes, apple exists. App does not exist. But if we search for, if the query is for startsWith, then yes, in this case we will return true because apple starts with app and we only have one word apple and it does start with app. We can return true. Then we insert app, so a separate word would be inserted again, app, and in this case p would be marked as the end of the word. So next time when we do a search operation for app, we'll return true. Okay. Now, before moving forward, let me just show you what trie data structure looks like and how do we generally use it. Okay. So you can see we have few words and dad, do. Okay. So this is the starting point for everything. We have A, N, D, and, right? Now at D, we'll mark D as the end of the word so that we know that and exists, A and D. Similarly, we have A, N. Up until now, the path is same. A has children N, A has child N has two children D and T. And we can go for T. So and exists. Similarly, from the root, there is another division which goes D and O, DO. So O must have been marked as end of the string. Similarly, we have D, A, D, and this D is marked as end of the word, right? So this way we can find out that if we are asked, does dad exist? Yes, it exists. Now if you want to find, is there a word that starts with DA? Yes, DA exists. Now for startsWith, we don't have to have the end of the word at A, right? This is how it happens that when you are typing A and the autocorrect would suggest A and D and A and T and, right? Since both of them are possible and you select D. So this is what we have to implement. Okay. Quick thing to note from here is one thing, we need nodes. So we need to create a node data structure, and then for each node we need few things. So if you see, few things would be, one could be a variable that marks whether this node is the end of the word or not. Another would be, we'll keep a track of children for each node, like A has one child N has two children D and T, right? Similarly, we have to take care of things like if it is the end of the word, or is how to mark a word as this would be the end, and to add child and to get the child. Like for if I'm at node A, I want to get the child, I should be able to get n, right? So let's jump back to the problem statement and start solving. So this is the data structure that we have to implement. Okay, so this is firstly, one more thing is that this is really not so frequently asked question for lower level interviews, but when you go for FANG level interviews, this is a must data structure to know about. So it will be interesting. Okay, now, so before we solve try, since we are not given anything else, we'll create a node class, right? Because as we see, we need a we need a node class, like in case of linked list. So we'll create our own node class, and we'll create subsequent methods that will be required to implement insert, search, and starts with, right? So just before solving, insert, the job is just to insert the word into the try data structure. Search will search for it. Starts with will just search that a prefix exists or not, right? Let's start now. So we'll create a class, we'll call it try node. Okay, then with each try node, what does it represent? So each try node represents a character in the try, right? As we saw, each node here represents a character in a try data structure. So this way we'll keep try node, and we need few variables. So we'll keep for this node, we need children, so we'll keep private try node would be the data type, and children. Similarly, private will keep boolean is end of word to mark end of word. So like in this case, D is the end of the word, so we know A and D, and now D is the end and exists, right? If there was some word character after D, we can say and it does not exist, but if you search for starts with A and D, yes, it does exist, right? So we need a variable, boolean variable, to mark each node as if it is end of the word or not, right? Similarly, we'll create the constructor public try node. What do we want here, right? We'll initialize the children, and we'll mark for the is end of the word as well. I'll comment for everything. So initialize the try node with an array of children. Now, since this is for characters, at max characters could be 26, so each node will be having max children of 26, right? Children, and we'll mark it here 26 characters, right? Not characters, let's keep it letters, so we know that they are the letters from the alphabet. And we'll set is end of word as false for the start, right? So we can say this dot children is equal to new try node of size 26 for 26 children, and this dot is end of word is equal to false. So one thing about Leetcode is we do not get the auto suggestion here or if it does, please let me know in the comment section. I'll enable it for at least for the longer problems. Okay, similarly we need other methods to get the children, to set the children, to get if it is the end of the word or not, right? So we'll take public, so that each time we are inserting a character, we'll add it as a child. So we'll say public try node. Why should we get child? Let's add child first. Add child. Okay, we are given a character. So if you consider this case, and is a string but a is a character, so we are asked to insert a, let's say. Okay, so create a new child node for the character ch, right? So we'll say try node. This is the data structure now. New node is equal to new try node, right? Now we'll say children ch minus a. So this is to represent the ASCII value. So if you convert ch into the characters, sorry, into integer, a stands at 97 in the ASCII value, small a. So if we get a, 97 minus 97 would be 0, and in children at 0th position, which is for a, will be setting the value, right? So is equal to new node. So we have created a new node at a, right? So then we'll simply return new node. That's it. Similarly, we need another method for getting this child. So we'll say public try node get child char ch. So for each character, if child exists, we'll return it, right? So get the child node corresponding to the character ch. So we'll say return children, and we'll search in the similar manner ch minus a. Okay. Similarly, we want to get and set is end of word or not, right? So you can say public boolean is end of word, and we'll say check if. Why check? We'll just simply return the boolean, right? So this is actually to check if it is end of the word or not, but we are returning the end of the word boolean for each node, right? So we can, I'll still write it as check if the current node represents the end of the word. So we'll simply say return and return, what's the name of our variable? Is the end of the word. Yeah. So return is end of the word. Am I writing it correct? Is end of word. Sorry, no the. So is end of word. Okay. Similarly, we'll set it. So public void set end of word, and we'll mark the current node as the end of the word, right? So when like when we are adding d, we'll mark it as the end of the word, right? Or let's say when we want to insert and into our try data structure, we'll insert a, we'll insert n, we'll insert d, and in the end, for the last character, we'll mark it as the end of the word. So we will simply say is end of word is equal to true for this current node. That's it. This is the prerequisite that we need for the try node. Now that we have created the try node, we can come to the problem statement that has been asked, and we'll complete it. Okay, let's create a node for this. So we'll call it private try node. Let's call it root. Okay. Now public try, this is where we'll initialize the try. So we can say initialize the try with an empty root. Okay, or root node. So we can say this dot root is equal to new try node, which is blank right now. Now let's come to the insert method. So we have to insert this word. Imagine we have to insert the word and a and d. So what will we do, right? Let me start with the comments. So we'll start from the root and insert each character. Insert each character of the word into the try. Okay, let me pull it a little on the left. Okay, so first let's create a new node for character a. So try node, or just simply let's create a new node first. try node is equal to root, which is pointing to root. Now we'll traverse through this word character by character. So for char ch from word dot to char array. Okay, now one by one we'll check if the node has a child for ch, because right now we do not know if ch already exists or not. This will be helpful in case when we are already at n and we have to we fetch the child n. Last time we had inserted a and d. Now from a we are fetching the child n, and then we are entering t. So we fetch the child if they exist, right? So we'll check if node dot get child ch is equal to null. So it will be null in the first attempt. So what can we say? If the child node doesn't exist, create a new node. Okay, so we'll say node dot add child. For, like, we can say for root right now, as we see, there are no child nodes in the beginning, right? It's all blank. So in the beginning there are no child nodes, so we first create the child node and we add it. So we'll say node dot add child ch, will pass the character. Once this if loop is complete, okay, that means we added the character. So a has been added, we need to move to the next. Okay, so move to the next level in the try. So we'll say node is equal to node dot get child ch. Now we'll come to a, this part. Earlier we were at root, we have inserted a, now we'll come at a. Similarly, the for loop will run again, we'll get the new character which is n, we'll insert n, we'll move to n, we'll insert d, we'll move to d. But now when we insert d in the end, we have to mark it as the end of the word, right? So once the for loop ends, once we have reached the end of the node for the current word, we'll mark it as the end of the word. So we'll say mark the last node as the end of the inserted word. So we'll say node dot is not is, what's the name of our method? Set end of the word, right? So we'll call node dot set end of word. That's it. This is all that we need in the insert method. Similarly, we have search method where we need to search for the word. So let's say we have to search for the word ant. This complete data structure, try data structure has been formed. We have inserted everything. Now we want to search for ant. So how will we begin? We'll start from the start. So start from the root and search for each character of the word in the try, of course. Okay, so we'll say try node is equal to root. That's where we'll start. We'll start traversing for ch, similar to how we did it while inserting word dot to character array. Okay, now we'll check if node has child. So node dot get child ch is equal to null, because if it does not have any children, it does not have any child ch. So we are at node, we are searching for ant. If it does not contain the first character, which is a, it cannot contain ant, right? So we can simply return false from here. So we'll say if the character is not found, return false, right? Because if a is not available, a and t is not available, return false. But otherwise, so let's say we found a, right? Let's move to the next node then. So move to the next not node, level in the try. So we found A, we move it to N. So actually we got to A, we were at root, we searched for A was found, otherwise we'll reach this loop, right? We move to next one, which is N. Okay, so we'll say node is equal to node dot get child ch. So first child will reach at A, then we'll start searching for N. Okay, now at the end, when this complete loop is done, if at any level we did not find, we did not enter this loop, that means the word exists. But what if we reach A and T, and after T there is one more character E, right? That, or instead of A and T, it is A N T I N A, antenna. So we can say ant does not exist, right? So we need to check if this T is the end of the word or not, right? So we'll say check if the last node is the or represents the end of the word. So we'll say return node dot is end of word. Otherwise it would just be that it contains ant, but is not ant. It starts with ant, like antenna starts with ant, but it does not contain ant. But in this case it does. So is end of word would be true. Okay, this way our search method is complete. Now let's similarly complete the starts with. In starts with, we'll not check for the end of the word. So I'll say start from the root and search for each character of the array of the prefix. Okay, so try node is equal to root. We started from root, we'll do the same check for ch. So it's character ch from prefix dot to char array. We'll check if, so first check would be to get the child. If it does not exist, we can return false. Node dot get child ch is equal to null. So we can say if the character is not found, return false, right? So as in this case, we have to search if prefix will give the prefix an, if prefix an starts with, so an and starts with an and ant starts with an, so this should return true, right? So first we searched for root has a child a, because if it does not have a, it will not have an, right? This is the same check as we did earlier. So if it does not have this child, we can simply say return false. Yeah, false. Otherwise we'll move to the next node, or next level, move to the next level. So we can say node is equal to node dot get child ch. That's it. And in the end, if after all this, while completing this complete for loop for the prefix, in this entire duration we do not enter this false, that means that this character, this prefix is available, and any word or a certain word starts with this prefix. Considering this prefix was n, so ant starts with an and ant starts with an, so that would be true. We do not have to check for end of the word or anything. We can simply say the prefix is present in the try, so return true. That's it. Okay, let's run it. I know this was pretty long, but please go through this video again if you're required to, because this is a very important data structure try, and this one question covers all the different segments that are required in the try data structure to understand try completely. Okay, and a lot of questions in the interviews do come around try data structure. Let's submit. Okay, beats 85.89% of users. Okay, so yeah, that's it, everyone. That's it from today's video. If you have anything, please let me know in the comment section. In the end, please like, share and subscribe. Thank you.